All right, in this video here, we are going to be looking at functions. Now, these are special math things that is introduced in algebra. And to kind of get us warmed up for it, we got the bottom half of this old board game. So now real quick, if you land on a spot that has a ladder, it's going to take you up there. And if you land on a space with a chute or a slide, it brings you down to that space there. So let's say you got a 2 on your last turn and you ended on space number 6 right here. Which space did you come from? Pause the video, see if you can get it. So check it out. So if we had started on space 4, 2 would have gotten us here. However, space 4 has a special function. It actually brings us up to this one here. However, if we started after getting the 2, if we started here and went 1, 2 to there, this slide would have brought us down to 6. So we would have had to start on number 14, then gotten the 2, and then we would have ended on number 6. So in this video, we got a lot to cover. We're going to go through identifying functions, looking at domain and range, and then using function notation to evaluate functions. A bunch to go over, so let's get into it. So here we go. So there's a bunch of ideas that are all connected when we talk about functions. So here we go. Independent variable, that's always going to be your x values. Dependent variable is always going to be your y values. We covered independent and dependent on the last video. If you need to see that, check that out. I'll have a link up here. Next up, domain. Domain is the list of values for the independent variable. This is new. We will cover this in this video here, and then the range goes with that, and that goes with the dependent variable. So, and that's the list of y values there. So the inputs are the x values, the outputs are the y values. Inputs, those are the x's, outputs. New one here is f of x is the way we say that. This is not f times x, it's f of x, and we'll go over that in this video also. So when you're looking at a table, left column is always your independent, your x's, your inputs, and the right-hand column is always the dependent, the y's, and the outputs. And then if you're looking at a graph, your horizontal axis is always called your x-axis, and then the vertical axis is also called the y-axis. So that'll be your dependent variables go there. So if you don't already have this in your notes, I do recommend go ahead and pause the video and get this in your notes. So let's look here. So we have some ordered pairs here, and we can think of these as inputs and outputs. So remember, x's go with your inputs. So the first number of each pair is, we can think of as inputs, which means the second number, the y values, those are going to be outputs. Okay, so we can also put these on a mapping diagram. So this isn't super duper common, but when we talk about functions, it can help us have a more visual look at what's going on. So there's our list of inputs, and here's our list of outputs from our ordered pairs up here. And then if we look here, a 2 for the input gives us a 2 for the output. So 2 goes to 2. And then over here, a 3 for the input gives us a 0 for the output. So 3 goes to 0. So we draw an arrow there. And then we have an input of 5 gives us an output of 9. So 5 goes to 9. So we draw an arrow from 5 to 9. So there we go. And that's what a mapping diagram looks like there. So let's go ahead and define domain and range. So domain is the list of x values, your independent variables, the first number on your ordered pairs, your x's, right? And then the range is the list of y values, what y's correspond with these x's up here. Now, quick note with this range that we're talking about is not the mean, median, and mode range. It's different, so try not to get that confused. If you're talking mean, median, and mode, that range is the biggest minus the smallest. This is a different range, so just keep that in mind. So now looking at the example we used on the last page there, here's all of our x's, 2, 3, and 5. 2, 3, and 5 are our inputs. So basically that's what your domain is. You're listing your possible inputs. So in this case here, it's 2, it's 3, and 5. Those are the 3 inputs that we can use. And then your range is the list of outputs. We got a 0, a 2, and a 9, or a 2, a 0, and a 9. Generally speaking, when we write these, we do them from smallest to biggest. So it is more appropriate to do 0, then the 2, then the 9. However, with a list, unless it says it has to be ordered, you can put them in any order. And we can also look at these on a graph. So remember the inputs, those are the x values, and it goes on the horizontal axis. And so for this case here, we have a 2 goes to a 2, and this 2 is the output, so it's going to go on the y-axis or the vertical axis. So we have 2 goes to 2 right there. And then a 3 goes to a 0. 3 for the x goes to a 0 on the y. Input of 3, output of 0 right on the x-axis there. And then the last input is a 5, and that goes to a 9. So there's our input of 5, goes all the way up to an output of 9 right there. And here's the ordered pairs again, just so we can go back through and look and make that comparison there. So again, on a graph or on the ordered pairs or on your mapping diagram, shows the same story, the same pieces of information. So we can also look and find domain and range from a graph. Now this is a little bit different than the last one because this is continuous versus discrete information. So the way we write our answer is going to be a little bit different, but the main idea is the same. Domain, those are your x values, okay? So you'll be looking at the x-axis. Range is your y value, so we'll be looking at the y-axis there. So here we go. For domain, we're looking for where the graph lives only in relationship to the x-axis. So we're just looking at these numbers in here. So the graph starts at 1, and then it's going to end at 5 on the x-axis. So starts at 1, ends at 5, and these are going to be x's, so x goes in the middle. And this is where it gets kind of tricky in here because these are always going to be less thans up here. Smallest number, biggest number, like that. So it's always going to be less thans with this type of compound inequality. So 1 is not part of the domain, so it gets a strictly less than. And then 5, that's a closed circle, so that is going to be part of the domain, so it gets a less than or equal to symbol there. So now for the range, we're going to look at the y values. So we're only looking at these ones here. So where does the graph live in comparison to the y coordinates there? So the smallest one is going to be a 4, and the biggest one is going to be a 6. So smallest is 4, biggest is 6, and these are y values. So we're going to write a y in the middle there. So in this case here, looking here at the range, 4 is included in the range because it's a closed circle, so it's less than or equal to. And then the 6 is not included because it's an open circle, so that's strictly less than. So with these, most people, they're okay with the domain looking at the x's. The part that they struggle with for most people is those y values there, is looking here and then going to the right. We're pretty used to looking up from the x-axis. It's this range part here. So just remember, range goes with a y, so we're looking at where does the graph live in comparison to the y-axis for the range, and where does it live for the domain, for the x-axis for the domain. So now we'll kind of switch gears a little bit. We're looking at the definition of a function. So for functions, each input goes to exactly one output, okay? So each x gets exactly one output. So each member of the domain, remember inputs go with domain, goes to exactly one output or member from the range. So here we go. We're going to determine whether this relation is a function. So we can put it on a graph if we want to look at it that way. So -2 goes to 1, -2 goes to 1, 0 goes to -1, 0 on the x, -1 on the y, right on the y-axis there. 2 goes to -3, 2 down to 3, and then 4 also goes to -3. 4 goes to -3. So now we're asking ourselves a question, because remember functions, we want to make sure that each x goes to exactly one y, and does that happen? This x goes to one y, this x one y, this x one y, this x one y. Same thing on the graph here. This x, there's one y, this x, one y, this x, one y, and this x, one y. So each x has exactly one y. So yes, this is a function. Quick review question. What's a domain? Right? So that goes with the inputs or the x's. So that's going to be our list of inputs either from here, or you can look on the graph. We got -2, 0, +2, and +4 looking from the graph. So again, -2, 0, 2, and +4. And then range, that's your list of outputs. So on the mapping, it shows up here, and then on the graph, it shows up on the y-axis, okay? So starting from smallest to biggest, we have a -3 there. So -3 is one of the members of the range, and then up to -1, we got a dot there, so that's also part of the range, and then +1 also has a dot there for +1 on the y-axis. And again, we can also look here to get that same information. How about this one? Determine if this one is a function, okay? So let's look here. Remember a function, each x goes to exactly 1y. So does this x go to 1y? Yep, it sure does. What about this x here? Oh, wait a minute. This x, it goes to a -2 and it goes to a +2. So this x right here goes to two different numbers. So no, this x has two outputs where we only wanted one output. So on a graph, it looks like this real quick. So -1 goes to 0 right on the x-axis, 1 goes to -2, 1 to -2, and 1 also goes to +2, 1 to +2, and then we have 3 goes to 4, 3 goes to 4 right there, 3 and 4. So if you notice here, we can also check out whether or not each x has exactly 1y on this. Over here, oh, this x that has 1y. This x here, look, it has two blue dots on that same column. So that means that this x of 1 has two different outputs there and there. So that's another way of checking to see if a function or if a relation is a function. And in this case here, we can see it on the graph. Speaking of graphs, basically on these ones here, we can do what's called a vertical line test. Remember, each x can have only can have one y that goes with it. So if we look over here at -4, this -4 for the input goes to one output right there. This -3, one output. This -2, one output. This -1 here, it has two different outputs. But wait, it gets even worse. Check this one out. This 0 has 1, 2, 3 outputs. So no, this is not going to be a function. So, and what we basically do is you can take your pencil or a piece of paper and you can just kind of draw or imagine straight lines going up and down or vertical lines going up and down. And if it crosses a graph more than once in any spot, then no, not a function. Here's another one here. So check it out. So at -4, it's 1 there, -3, 1 there, -2, 1 there, -1, 1 there. In fact, the more vertical lines we draw, we still, the yellow lines still just cross the blue graph just once. So yes, this one is going to be a function. How about these guys here? Let's look at this oval right here, this ellipse if we want. That one's fine, that one's fine, that one's fine. Even -1 is fine because it only crosses once there. But check it out. As soon as we get to 0, there we go. We have two different spots where the yellow line crosses the blue graph. So no, not a function there. And then this line here, this one's pretty basic, pretty simple. Crosses once, crosses once, crosses once. So yeah, so this one will be a function. So again, that's called the vertical line test. So you're just doing vertical lines. You can do it with your pencil and just kind of scroll across your piece of paper or the screen if you're doing it online. And anytime your pencil crosses your blue graph or whatever color it is more than once, then not a function. Okay, we can also identify functions looking at tables. So remember, we want to make sure that each value of x goes to exactly one y, or each input goes to exactly one output. So inputs are always going to be the left column, and outputs always going to be the right column. So here we go. -1 goes to -2. That's good. 3 goes to 2. 3 also goes to 5. This one's not going to be a function because the input of 3 has two different outputs. It has a 2 and a 5. So this one, nope, not a function. Let's look at this guy here. This x, 1y. This x, 1y. This x, 5 goes to 6. 9 goes to 7. 15 goes to 4. Each of these inputs goes to exactly one output. So yeah, that one is going to be a function. That one's good. Now let's check this one out. 0 goes to -4. 1 goes to 3. 6 goes to 5. 7 goes to 9. 1 also goes to 11. So there we go. So this input of 1 has two different outputs here and here. So no, not a function. And then our last one here is a function. Now this one's kind of tricky because check it out. We have 0 goes to -2, 3 goes to 1, 5 also goes to 1. 9 goes to 7, and 16 goes to 12. Well, here, this input, one output. This input, one output. You can have your outputs repeated. That's fine. That's still going to make a function. But if your inputs are repeated, that means, or your x's get repeated here or here, that means that you have one input that has two different outputs. So you're basically looking at that column for the inputs or the x's when it comes to the tables. So here we go. Go ahead and pause the video, try this one out, and come on back, see how you did. So for this situation here, we have a list of ordered pairs, and we're going to make a table and then a graph, and we'll also do a bonus mapping diagram. So there's our table. -2 goes to 5, -2 goes to 5, -1 goes to 4, -1 goes to 4, 1 goes to 3, 1 goes to 3, 2 goes to 4, 2 goes to 4. So there we go. So that's the table part of the question. Now if we do a graph, that's what the graph will look like there. So again, -2 goes to 5, -2 goes to 5 right there, and then -1 goes to 4, -1 goes to 4, and you can go off of these as well, 1 to 3, 1 for the input, 3 for the output, and 2 to 4 there, 2 for the x, 4 for the y, goes right there. Now the mapping diagram will look like this. So we just list all of our x's, -2, -1, 1, and 2, whoosh, right there. There's our list of inputs, and then our outputs, 5, 4, 3, and 4. We don't write 2 4s. You only need one of each number for your outputs or your inputs. You only put one of each number. You don't double it up. So you're not going to have 2 4s there in your list. So, and then like from here or even here, -2 goes to 5, so you draw an arrow, -2 to 5. Draw an arrow from -1 to 4, -1 to 4, from 1 to 3, 1 to 3, 2 to 4, 2 goes to 4. So there's our mapping diagram. So next up, identify domain and range right there. So domain, that's where we're listing out our x values. So you can go straight off of here if you want, -2, -1, 1, and 2 right there. And then the range, that's your list of y values or outputs. And if you got the mapping diagram, you can use that. You can use your graph here. It looks like we got a dot on the 3, we got dots on the 4, and we have a dot on the 5. So 3, 4, and 5. 3, 4, and 5 right there. So you can do it in any order here. Most of the time, this does not have to be an ordered list, although it is more appropriate to write it as an ordered list. So from smallest to biggest. Now, is a relation a function? So do we have one x, or each x goes to exactly one y? So -2, that has one y. -1, one y there. There we go. 1 goes to one y, 2 goes to one y there. Same thing off the table, which we just did on the last page. Mapping diagram goes to 1, goes to 1, goes to 1, goes to 1. We're good there. And same thing from here. So yes, this one is a function. So now let's switch gears again, and we're going to look at what a function rule is. So basically a function rule, it's kind of like a formula, or it's similar to an equation or an expression type of idea. So we know that something is in function notation if we see that instead of a y, we have f of x instead of a y. So when we're first starting out, we kind of just say, well, just pretend the f of x is a y, because they're kind of interchangeable at this stage in math, although there's a lot of subtleties when it comes to using f of x versus y, okay? So we'll get into some of those here as we move along. So here we go. So remember the function rule that shows a relationship between the inputs and the outputs. And so like on this one here, there's our inputs, that's an x, and here's our function rule. It's 2 times whatever the input is minus 1. So let's say we have an input of 11. Well, here we go. This is our rule. We're going to multiply by 2 and then subtract 1. So multiply by 2 makes 22, and then subtract 1 makes 21. So we kind of think of these functions as kind of a machine. You have an input, it's normally a number in math, and then you do all the little works that you're supposed to do, in this case evaluate or order of operations, and then there's your output there. So that's kind of one of those subtleties with functions versus just plain old equations. So let's just do a quick review example, make sure we're all the way up to speed here. So let's say, we're going to write an equation type of idea. So it's going to be called a function though, because this is a little bit different. So we're going to be using f of x instead of y. Okay, so f of x is the output instead of y, and then x is the input. So here we go, the output. So we're going to start with the output. What was the output again? Oh, it says right here, f of x is the output. So we're going to write f of x on our piece of paper. Next up is. Normally in math, is means equals, okay? Next up, 5 less. 5 less does mean subtract 5. Subtract 5 from what? subtract 5 from 7 times, so that's going to be a 7. 7 times what? 7 times the input. Remember the input? It says right here, x is the input, x, right there. So that's what our function is going to look like. And it does look kind of like an equation, except we have a function notation here, f of x instead of y. But it does give us the information that we want to do. We want to take our input and multiply it by 7 and subtract 5. So subtract 5 from 7 times the input. So here it is in words, and this is a shorter summary. So this takes up like a line on your piece of paper, whereas this guy here, he only takes up like a quarter of a line. So it's a summary because it's a lot shorter on your piece of paper versus this, even though it has the exact same information. So we're going to go into using these functions and just learning kind of how the language of math works with these. So here we go. So for f of x equals 3x plus 2, so there's our function, find f of 7. So when you see it like this, that basically means that you're going to replace the x's with a 7. So check it out here. We have f of x. This is f of 7. Well, what changed? Well, x changed to a 7. So that's what you're going to do. So this is telling you what your input needs to be. It's the x is the input, so 7 is the input. So we're basically going to take our function and we're going to replace all the x's with what value? 7. It says so right here. So here we go. So 7's going there and there. So now we just do order of operation. So 3 times 7, right? Multiply first. That's going to make 21. And then we still need to add 2 to that. So here we go. 21 plus 2 makes 23. So the way we read our answer is f of 7 equals 23. Now, the reason why this is kind of the direction we're going with math is because in order to give the same amount of information in words, you would have to say this. You would have to say when x equals 7, then the y equals 23. Or when the input is 7, then the output is 23. Well, this is a whole lot more compact than this whole sentence here. Now, it's also shown, you can do these on tables or an ordered pair or something like that. And this basically gives the same information. This is a little bit more specific, and this is the direction that math is kind of going. All right, so here's another one where we're evaluating a function. Go ahead and pause the video, try this one out. Come on back, see how you did. So here we go. We're going to find f of negative 3 when f of x equals x squared plus 2x plus 3. So remember here, what changed? We have f of x. Here we have f of negative 3. So what this is telling us to do is replace the x, because the x changed to a negative 3. So that's what we're going to do. We're going to change the x's, that x, and that x with the value here, f of negative 3. So we're going to put negative 3's in there, there, and there. And now we just do order of operations. So here we go. Exponents first. So when we simplify, exponents first. So negative 3 times itself, or 2 negative 3's being multiplied, or negative 3 squared makes a positive 9. So exponents are done. Now multiplication. We have a positive 2 times a negative 3, so that makes negative 6. And then we still have the constant there, plus 3. Now we're ready just to add like terms. So if you want to kind of change the order up to make it easier, I normally do all the positives first and then subtract at the end. So add up all the positives, add up all the negatives, and then subtract at the end. So this would be a 9, and the plus goes with a 3. That minus goes with a 6. So it's 9 plus 3 is 12. 12 minus 6 makes 6. Okay? So again, the way we read this is f of negative 3 equals 6. Okay, and again, the meaning behind this notation is this. It means when I have an input of negative 3, then my output is going to be 6. So this is a lot more compact because there's more information in this notation than in this x equals y equals notation. So just make sure that you're connecting up all of these ideas in your brain. Taken as a whole, there's a bunch here, but each idea on its own isn't super confusing, right? X values is your independent variable. Your domain is you're just listing out all the different inputs. The range, you're just listing out all the different outputs or the corresponding outputs, right? We have inputs are X, outputs are f of x. So the ones in yellow are the new ones in this video here. But do make sure that you got all these in your notes. It's totally going to help your brain connect up all these dots, all these different weird ideas and new words.